Hello everybody. In our today's video we are going to discuss about selection sort algorithm. It is one of the sorting algorithm that basically used to sort list of number into ascending order. So I will give brief idea about how your selection sort algorithm will convert list of number into ascending order. We will discuss with one example, and then we will discuss a time complexity of selection sort algorithm, and at the end we will discuss pseudocode of selection sort algorithm. So let us start our today's video on selection sort algorithm. As I said, we will discuss with one example. So first of all, try to understand the concept of selection sort algorithm with one example. So let us have one example. Suppose we have a list of 5 numbers, 52, 8, 27, 3 and 1. Now we want to convert this random list of number into ascending order by using selection sort algorithm, right? So as per the selection sort algorithm, first step is we have to identify the minimum number from this list. So first basic concept of selection sort algorithm is, from this list you have to identify which one is the smallest element, and the smallest element we have to swap with the first element. Right, so for example, here the smallest element is 1, then this 1 must be swapped with the first element because this is the correct position for this 1. Then after we have to start from the second element. Again we have to find the smallest element among all, and we have to swap with the second element. So continuously we have to do same process so that we can convert list of number into ascending order, and this concept is known as selection sort algorithm. Every time we are selecting one smallest element and we are storing one appropriate position, so that it is known as selection sort algorithm. So let us start our selection sort algorithm. As I said, we have to identify minimum number. If we have a different 5 numbers here, then how we can find minimum number? So first step is we have to assume that our first number is a minimum number. So assume that 52 is a minimum number. Now we have to compare this 52 with next element, that is 8. If your next element is minimum than this minimum 52, suppose, then we have to consider next element as a minimum number. So in our case, our second element 8 is a minimum than the 52. So now our next minimum element is our 8. Again we have to compare with 27. So 27 is not the minimum than 8. So 8 is, as it is, minimum number. Then compare this 8 with the 3, whether 3 is minimum than the 8 or not. So condition is true, 3 is minimum than the 8. So now our next minimum number is 3. Now compare with 1, then 3 is greater than the 1, or 1 is minimum than the 3, so that we can say our minimum number is 1, right? So we have to do this process from first element to the last element, and we have to identify which one is the smallest element. So out of this range, out of this all the elements, we have a smallest element, that is 1, right? So as I said, we have to swap the smallest element with the first element. So our next step is swap the smallest element with the first element, that is 52. So 52 and 1 will be interchanged, and we can get value like 1, 8, 27, 3 and 52, right? So remaining elements are as it is, 8, 27 and 3 will be on same position. We are just interchange the value of 1 value, that is 1, and 52. Now here we have to check how many comparisons are required when we find minimum number. So we have for example 5 numbers, then 4 number of comparison is required, because we have compared 52 with 8, then with 27, with 3 and with 1. So total 4 comparisons required, and our total number of elements are 5, so that we can say n minus 1 comparison is required, right? Now we have interchanged our 1, which is a minimum number, and we have swapped with the first element. So 1 is now on appropriate, or we can say correct position. So now we will not touch this one, because 1 is on correct position. So we have to start from the second element. Now we have to identify which one is a minimum number, or we can say smallest element, from second element to the last element, right? So consider this element as a minimum number. So now assume that this 8 is a minimum number, and do same process what we did. We have to compare 8 with our next element, that is 27. So 27 is not minimum than the 8, so minimum number 8 is as it is. Now compare 8 with 3, so 3 is minimum than the 8, so our next minimum number is 3. Now compare 3 with 52, then 52 is not the minimum number than the 3, so that our minimum number is 3. So 3 is a minimum number. We have to swap this 3 with our second element, that is 8. So there will be swapping between these two numbers 3 and 8, because 3 is the smallest element, and we have to swap with the next element, that is our 8. Right? In this case, how many comparison we did? We have not compared our first element because it is on a correct position, so we have to compare n minus 2 comparison. So there will be 8 minus 2 comparison. For example, total number of elements are 5, then we have a 1, 2 and 3 comparison, so it is n minus 2 comparison. Right? Now interchange this, both the value 3 will be here and 8 will be here, so that we can get our next list, that is 1, 3, 27, 8 and 52. Now 1 is on correct position as well as 3 is on correct position, so now we will not touch 1 and 3, and we will start from the third element, that is 27. Assume that 27 is a minimum number. Then we have to compare this 27 with 8 and 52 in our next step. So now compare 22 with the 8, whether 8 is minimum than the 27 or not. Yes, here 8 is minimum than the 27, so our next minimum number is 8. Again we have to compare this 8 with the 52, whether 52 is minimum than the 8 or not, but the condition is true, 52 is not minimum, so that our minimum number is 8. Right? So our 8 is a minimum number that we have to swap with the 27. So there will be swapping between these two number 8 and 27. So our next list will be 1, 3, 8, 27 and 52. Again we have to check how many comparisons required. In this case, total number of comparison will be n minus 3. Right? And our next position will be on next element, that is 27. Again we have to do same process. We have to assume that this number is a minimum number, and then compare this number with the next element, that is 52. But 52 is not the minimum than the 27, so our minimum number will be 27 only, and there is no swapping between these two number, 27 as it is. Then our next element is 52, and 52 only one element is available. Then after there is no any element, so it will be swapped as it is, it will be there as it is, so there is no chance, and we can get list of number into ascending order like 1, 3, 8, 27 and 52. Right? This process is simply known as selection sort algorithm, because we are selecting minimum number from the list every time, and we are putting in appropriate position, so that it is known as selection sort algorithm. Now what is time complexity of the selection sort algorithm? As we discussed, first time we have n minus 1 comparison, then after n minus 2 comparison, then after n minus 3 comparison, right? So every time we have a different comparison like that, and so that we can write same formula like n into n minus 1 divided by 2. This formula we can write n into n minus 1 divided by 2, so that the time complexity of this algorithm is again order of n square. Right? So this is again the time complexity of selection sort is also order of n square. Now let us discuss the pseudocode of selection sort algorithm. As you know that algorithm is simple, known as a function. So we are just creating one function, and name of the function is selection sort. We are passing list of number as an argument. We are passing, for example, 5 element or 10 element as an argument. In this algorithm, we have a two loop. One is for loop, outer loop, and second one is inner loop. This outer loop is basically for the different passes, and this inner loop basically used to find the minimum number, because in every step we are finding minimum number, and then we are swapping with the first element, then second element, then after third element, etc. Right? So this for loop will find which one is the minimum number, and then this part will swap with the first element, second time it is second element, third time it will be with the third element, right? So this is just selection sort algorithm to sort list of number into ascending order. So as we discussed from this code, from this pseudocode also we can say that the time complexity of selection sort will be definitely order of n square, because we have a two loop and it is a nesting of a loop. And if we assume that in worst case both loop will be executed n or near to n, then the time complexity will be definitely t of n belongs to order of n square, right? So this is all about selection sort algorithm. Thank you very much.